All right. Here we go, 8.3. So, Math 9 8.3. You can get your textbook out if you wish. Math makes sense. Pearson, math makes sense. Doesn't math make a lot of sense, guys? Come on. No. Any votes? Sometimes. No. Okay. You know, we should have a little sometimes behind there. Math makes sense. Sometimes. With like a question mark? I don't know.
Hello, high school.
Oh, hello, high school. It's a big announcement. All right, so what are we going to do today? We are going to focus on discovering the properties of inscribed angles. Ooh, there's a word we haven't seen yet. Inscribed. Okay, I'm looking at this word, and I'm seeing scribe. Okay, scribe means to like write or to draw or to record. And then I'm seeing the word inscribed. So at angles that are written inside or written in, okay? Drawn in, sketched in. That's how you remember how that works, because I'll tell you in a second what these actually are. Central angles, well, that's pretty easy, right? Angles associated with the center. And then solve related problems. All right. So, the measure of a central angle. Now, the central angle is the angle that is made by two radii, right? They emanate from the vertex is the center of the circle, and the arms or the rays of the angle are radii, or two radiuses, right? So that's the central angle right here. Now, pretty cool is that an inscribed angle would be an angle that is made by the end points of the rays of the angle are on the circle, and the vertex is also on the circle. So all points of the angle that's made by the two segments, 1, 2, 3, all those points are on the circle. So it's drawn completely in the circle, okay? So inscribed. Now, what does it say? The measure of the central angle is twice the measure of an inscribed angle, subtended by the same arc. Have we talked about subtended yet? I thought maybe we did first class in this, or first chapter, first section. But the subtended, sub means kind of inside. Tend, if you tend to something, that means you're kind of taking care of it. You're tending a garden, or you're tending to a task. So that means you're kind of like taking care of it, you're laying hold of it. Okay, so sub is inside, laying hold of the arc. Okay, so in inside subtended arc, so it kind of controls or tends to the arc. Okay, so it's the arc inside the angle rays. So this is an arc, that's an arc, and we talked about minor arcs and major arcs, right? So if the central angle and an inscribed angle, where this point is anywhere on the circle, if they subtend the exact same arc, then the inscribed circle is half of the central circle, or central angle. The inscribed angle is half of the central angle. Okay? So think about it this way, and I mean, I don't know if this is the correct way to think about it. It's not mathematically proven, but this is the way I remember it. Okay? This might be good for you. So think about this. This center, okay, point is this far, the radius far from here. Now you have to go twice as far to get this one. So if you stretch something out twice as far, and the endpoints of the angle are at the same spot, as that vertex goes out further, the angle kind of gets smaller, right? It kind of like starts to face out. So it's like, oh, that makes sense. Now this point, and I'll show you later, this point could be over here somewhere. The vertex, or it could be way over here. So we'll sketch some possibilities and show you how this works, but if you understand this, you'll be able to tell me what angle x is, because the central angle here and angle x subtend the same arc. So x is 35, right? So x is 1/2 of 70, which equals 35 degrees. Excellent. And you can kind of see, right? One angle looks bigger than the other, so you know which one's the double and which one's the half. So y, is y going to be 9? Are we talking about half, right? Y is 9, or? Oh, it's not 9, it's not half. Y looks to be bigger. They're subtending the same angle, same arc, so 18 is the half, and y would be the double. So y is? Very good. 2 times 18 is 36, so y is 36, and that's, of course, in degrees. Love it. Anybody have any questions about this so far? This is a very simple, I think it's a pretty straightforward rule or theorem here in math, a property. But anybody have any questions? Okay. let's take a look at a little more difficult examples. Now, the inscribed angles subtended by the same arc, those inscribed angles can have, as I mentioned just a few minutes ago, a vertex that is anywhere on the circle, anywhere, as long as the opening is the same as the central angle. Okay, see this opening here, or this arc is the same. So if this is an angle represented by 2x, any of these angles would be 1x. And of course you could keep going. I could go way over here too. And if I drew nice straight lines, here I'll do my best, straight line all the way over to here, and then a straight line all the way over to here, guess what? That is still x. Because it opens up to subtend the exact same arc. Okay? Now, this question right here, I don't think you have this in your notes. Oh, you do have this in your notes. Okay, I made this up last minute, so it is in your notes there. So you don't have to redraw this. That's nice. Okay. But given that this angle is 42 in the black here, which angles, now think about this for a second, which angles are 21? I have the option of A here, let's say A is this one, B, C, D, or this big one, E. So which one or ones are 21 degrees? Anybody? Yeah, name one. D. Who agrees with D? Okay, let's trace it. So D is, the vertex is here, and it goes from here all the way to this little point vertex from here. Does it subtend the same arc as 42? It does. Is it an inscribed angle? Yes, the point is on the circle, so that meets both conditions. D is correct. D is 21. Very good. Okay. What else? What's another one? There's one more. Anybody else? B? You think B? Okay, let's check B. Here's B right here. So this B is formed by this line segment and this line segment. So it subtends the exact same arc, and the vertex is on the circle somewhere. Perfect. B and D, yes, are angle B and angle D are the solutions here. Okay, now angle C and E and A, right now we don't really have an idea of what those are. We don't have to worry about those ones, but you should know that angle B and D are 21 half of 42. Okay, any questions? We could figure these angles out. We certainly could, but we're not going to do that right now. Okay, next page. Let's see what's up here now. Let's solve some related problems maybe. Okay. Okay, actually that's a good question before we move on. Let's consider that. So is E 21 as well? Because E subtends the exact same arc as 42. So is E 21 as well? We might have missed one. What do you think? It subtends the same arc, doesn't it? Does it satisfy the other condition that the vertex of this angle would be on the circle somewhere? Yeah, the vertex is right here. That's not on the circle. That vertex would have to be somewhere on the outer edge of the circle. But I'm glad you mentioned that as a possibility, because that's a good thing for us to take note of. That's an example that's close, but that's not that's not 21. And you can kind of see I sort of drew this to scale. So E is definitely bigger than 42, isn't it? Yeah. But if this point right here were to be pulled, stretched out way to here, let's say, then we would have this going on. And then, yes, then this one would be 21. Okay. All right. Excellent. That's a oh, erased my circle. That's an excellent example. What? Oh man, I don't know. Computers, technology. I mean, computers aren't going to last. It's a fad. We're gonna be pretty soon. We're gonna be inventing. I'm proposing inventing something called paper and a pen, and we're gonna be able to draw on this and like keep this. And it's not going to crash on us. What do you think? It's the wave of the future.
Yeah. Is it indestructible?
Brilliant. Is it indestructible? Pretty much, unless you destruct it. Kidding. I think computers might be around to stay. Okay, example one. Find the measures of angle x and y, and I think all the answers are actually here for you. I probably didn't blank these out. So let's take a look. Angle ACB. Oh, very important, guys. Very important. Please, you need to know how to read this. So this is angle ACB. Guys listening? Angle ACB. C is the vertex. The letter that's in the middle is always the vertex. This is the point. The first letter is the point on one of the arms. The last letter is the point on the other arm. So you just basically follow A, C, B, okay? Now that means that's angle 22 there. See that? You need to understand that, all right? You can't just say, don't say this. Don't say D is X. You see that? Because some people do that. I've seen that before. D is X. No, D is not X. D is a point on the circle. It has nothing to do with the angle. You need more information to identify this. Besides, why is it not this angle or all of these angles together, right? So you need some more information, so don't do that. It's not even angle D. No, that's not true. That's just a point on the circle. Need more information, okay? So don't do that. Angle ACB and ADB are inscribed angles, okay? And they encompass the same arc or subtend the same arc AB. So angle ACB is equal to angle ADB. Okay, so you guys get that? These angles have to be the same. X has to be 22 because they both follow all the conditions for inscribed angles and central angles. So what is X? Well, X is, or angle X, let's say, is 22 degrees. Very good. Okay, awesome. Now, what about angle Y? Central angle AOB. AOB, that's like, I think somebody from Star Wars. AOB, General AOB. Oh, that's Obi-Wan Kenobi, sorry. It's pretty close. AOB. Central angle AOB and inscribed angle ACB are both subtended by arc AB. Nice. So angle AOB is 2 times this other angle. So Y is 2 times what? 22. 44. You guys are quick, like lightning. Okay, Y equals angle Y. Good idea to put angle in front of the letter, okay, if it's an angle. If you just put Y equals 44, it could be really confusing as to whether that's a length or not, you know. So put the degrees, put the little angle sign, please. Just like this. Angle X equals 22 what? Degrees. Excellent. Okay, any questions there? I feel like this is super easy. Is this super easy? This is like super easy. Okay, this is super easy. All right. I promise I'll try and make it a little more difficult for you. I don't want to insult your intelligence. No, I can try. It's okay. No, it's all right. Oh, now you're struggling. Okay. Okay. All right. All right. As we continue.
I learned this lesson already, though.
Oh, you did?
I was watching it in study hall, so does that count?
I haven't recorded this lesson yet, so I'm recording it right now, so you haven't watched this one.
And I know that because I looked on that, but I was watching other videos.
Oh, you looked ahead.
I know that
okay.
The angle is half.
Okay, the angle's half. See, it's so easy, even Mrs. G understands
I could figure it out.
See that?
Even though the video wasn't there, there's other videos that you can watch.
Well, good strategy. Okay, so ACB and ADB are inscribed angles. We can see that. ACB is this one. ADB is this one. And they're subtended by the same arc AB. So they have to be the same. This seems like the exact same as the first one. So angle X is?
14.
Oh, yes. I know, your little baby siblings could probably do this question. Okay. What about Y? I'm not even going to read this because it's the same as before. Y is?
28.
Angle Y is? Yes, 2 times 14, 28 degrees. Lovely. All right, that's like super easy. Okay, this seems to be also super easy. We have 3 examples, pretty much exactly the same. Now, I think you guys have to make a slight change. There's a typo there, though. This would be angle ACB. So you might have something, a typo there. Looks like I've adjusted this. Yeah, it should be ACB. Angle ACB equals angle ADB. Yeah, which is half of this central angle. So angle X is 25 degrees. Good, it's half of 50. And angle Y is also 25 degrees. Excellent. Okay. Next page. Okay. Oh, yeah. So this is also important, but this is the exact same property, but it has a special name because the central angle, listen to this, the central angle now is 180 degrees. Whoa, what? Yeah, the central angle, here's the center. The central angle is 180 degrees. That's a diameter. You see that? You have a circle, you have a central angle like this, Oh, it's pretty big, right? Let's make it bigger. Okay. Okay, that's an angle that's larger. Awesome. Let's make it even bigger. Let's make it 180 degrees. That's a diameter. So, if you have an inscribed angle that subtends exactly half of the circle, or subtends a semicircle, then guess what? That inscribed angle is half of 180, or 90 degrees. And this property is used a ton in math. It is, in geometry. Even more than the other ones. You see this pop up more often. So, we'll read it carefully. Inscribed angles subtended by a semicircle, that's exactly half the circle, are right angles, because 90 is half of 180. And that goes for anything. So I can draw anywhere on here. Boom, that's a right angle. I can draw one down here. Boom, that's 90 degrees exactly. So cool. The vertex is, the vertex is on the circle. So the vertex, like this. Do you mean the vertex of the diameter of what would be the 180 degrees?
Yeah.
So the vertex of what would be the central angle here would be the center of the circle, just like the other ones, just like the other examples. So center, right? If that was an angle x, then this angle would be 1/2 x, right? That's 1/2 x. So if this central angle is 180 degrees, then the inscribed circle subtending that same arc would be 90, half of 180. So it doesn't even look like there's a central angle there, right? But the central angle technically is 180. That's why this works. That make sense? That's a lot of words there, but hopefully you're understanding. So if you have a diameter and you have a point on the circle and you connect the edge of the diameter with the other edge of the diameter, that's always going to be 90 degrees. Always 90, always 90. Okay? All right. Now we have a triangle that is inscribed in a circle, and one of the sides happens to be the diameter. Huh, interesting. Now you can solve a problem like this, and this isn't as drop-dead easy as the last set of examples. Not as easy. However, x and y you know right away, because this angle x, which is, n is disappeared. That should be an n, I think, right there. So angle MIN is this angle x, angle MIN. What's the angle measure for MIN? Yeah, it's 90. It's half of 180. Or this is a diameter. This is an inscribed angle with the same arc. So it's 90. Awesome. And because I know two angles in a triangle, I can find the third really easy. I go 180 minus this x1 is 90 minus the other one I'm given, 40 equals angle y. So that's 90 minus 40 is 50 degrees. What do you think? You guys like it? Does that look right? Because 40 and 50 and 90 equal 180. Awesome. Questions? Okay. Find the missing angle measures. Well, we did that just up here. Find angle. Wait, what? Oh, do you guys have a picture on the next page, or is this just my formatting?
It's on the next page.
Okay. So, you guys do this one. You guys do this one on your own. This is easy. You guys got this. You guys got this. Find angle x, find angle y. Yeah, on the next page. Sorry, the formatting there was a little goofy. So this is an example from your textbook here, which looks a little different from the easy ones we've been doing, right? So let's see if we can take the easy type questions, the basic concepts of this lesson, and apply them to this question, okay? So I've never done this question before either, but we'll see. I mean, it's been a while. So triangle ABC is inscribed in a circle. So here's A, right? B, C, okay? That's the circle, or the triangle inside the circle. We have a center O. Okay, so this is O at the center right here. And A, where AOB is 100, it's shown there. COB is 140, it's shown there. Determine the angles of X, Y, and Z. Okay, so X is this one, Y is this whole thing here, and Z, it looks like it's just this little one here. Not the whole thing, but just this little one. Okay. So which one do you think we can find first?
X.
Okay, X. Somebody said X right away. Now Y. I mean, not Y the letter, but Y. W-H-Y.
You
Wha-
have two other measurements that you can subtract out from 60 because it's a
Okay. Yes, you're very, very close. Your thinking is correct. We have two other angles as part of this larger central angle. Now, you said 160. It's actually 360, probably what you meant to say.
yeah.
But did you know that 100 degrees, this one here, plus 140 degrees, this one here, plus X, this one here, that actually adds up to a complete circle. And we know that the angle degrees in a complete circle is 360. So 360 has to equal this sum. So let's do 360 minus 100 minus 140. That should equal X. So what's that? 260, 160, 120. So angle X is 120. You guys okay with that? You guys agree with that? Okay. That's a great way to start. That's a great way to start. Now, the other ones. The other ones. Let's see. Does anyone see anything that we might be able to figure out here? X and Y. It's maybe a little tricky. I don't know. What do you think? Okay, sorry. Say that again a little bit louder. 180 minus 100 minus...
Divided by 2.
Oh, divided by 2. So 180 minus 100 divided by 2. What will that give you? That will give you Y. You know, that would give you this angle and this angle, but Y actually is this whole angle of this larger triangle. So you're close. You're close. Thank you. You could do this with Z, couldn't you? Because we have this angle, which is 120, and this is an isosceles triangle here. I'll highlight it in blue. This is an isosceles triangle right here. Good. Which means that these two are the same. That means that this guy right here is also Z. Okay. So let's do that in blue. So I have 180 minus this angle, which is 120 now we just found, minus Z is equal to 180, or actually another way to put that would be, let's say 2Z plus 120 equals 180, right? So this would have to be equal to 0, but that doesn't make as much sense to you. So let's try it again. Let's say,
Mr. Max.
yep.
How do you get 180? Just to remind us.
Oh yeah, so all the angles of a triangle have to add up to 180. So all the angles of a triangle have to add up to 180 degrees. All three angles. Okay? So 2Z plus 120 equals 180 degrees. You have two missing angles, but you only have one missing variable. So you can solve this easily. As long as you have an equation with only one missing variable, you can always solve it. Well, pretty much always. That's what you're looking for. So let's subtract 120 from both sides. Minus 120. So what's that going to be? 60? Okay. Divide by 2. Z equals 30. Okay. Do you guys like that? I like that. All right. Ah, I like that. Okay. So now how are we going to find Y here?
So you're going to use X because you already know that angle. And
Okay.
since, A, B, and C are whatever, you're going to divide that by 2 to get 1.
Oh, I see. So you're saying that because X is a central angle and it subtends this arc AC? Oh, and you're saying that this angle Y is an inscribed angle that subtends the same arc. Oh, so Y is going to be, angle Y is going to be 120 degrees divided by 2. Is that what you meant? That's what you said. Good job. 120 degrees over 2. So that equals 60.
Nice.
Hey? It can be done. Right? Good job. Okay, so yeah, so you would circle your answers and, just do that real quick, so I will too. equals angle, say y? What, something disappeared on me, didn't it? Okay. Good? Even though it looks a little crazy, but that's exactly what you gotta do. You gotta take the whole jumbled mess there and say, okay, what can I find first? What do I know? There's one you can find first pretty easy, probably, which is that x, right? And then the other ones, you gotta maybe think about it, but you can do it. Don't give up. All right, let's go back to the textbook here. Okay, so, oh yeah, we can check our answers in the textbook, I guess. Did we get those right? 120, y is 60, z 30. I like it. Okay, look at that guy. That's quite the boot. He's really putting into it. Okay. All right, let's just take a quick peek at this these assignment questions here. Ooh, this one looks really weird. That one looks really weird. Not quite like the diagrams we've drawn, but let me just show you something. Even though it looks weird, if you can try to pick out, you know, the property here. So this is a central angle, isn't it? And this is an inscribed angle that subtends the same arc. So whatever angle POQ is, PRQ will be, well, not the same. It looks pretty close to the same, but it's actually should be half. Yeah, this actually is bigger and this one is smaller, because this is a central angle, this is an inscribed angle. So keep that in mind. Again, angle POQ, oops, that's a G, no, it's a Q, is related to angle PRQ, but angle PRQ is 1/2 of this one. So 1/2 of the central angle is this angle. That make sense? It doesn't look like it there. It maybe is misleading, I think. But even though they cross over like that, it's the same as this angle. Same as this one. There and there. Okay. All right. Okay, 3 to 6, 8, 11, and 15 on page 410. Math makes sense. Pearson, 8.3.